Hey guys, welcome to Science with Miss Shoemaker today. So today we're going to talk about circuits, and I love circuits. And sadly, I don't have any here at home with me. So we're just going to have to look at some pictures. Okay, so bear with me. So as a reminder, we're going to start with talking about what an open circuit and a closed circuit are. So an open circuit means that there is no flow of electricity going all the way through. If it's open, it's broken. So if you look at the picture there on the left, we have an open circuit because the wires are not connected. Therefore, the flow from the positive end of the battery cannot reach the battery to go back to the negative end. So if it's open, it's broken and the flow does not go through. It is not going to turn anything on. Now, if you have a closed circuit, that means it's going to flow. The energy is going from the positive through to what it's powering down to the negative, and it's a complete flow of electricity. Your light will turn on, or whatever you're trying to power will turn on. So if it's closed, it flows, but if it's open, it is broken. It is not going to work. Now, there are two other types of circuits, which is what we're going to focus on today. So we have a series and a parallel. So a series circuit has only one path. So through that one path, it could have multiple things to work, like illuminate or turn on. So on this example, we have two light bulbs, but only one path. There's only one loop of electricity flowing through from that battery. That's a series circuit, one path as it goes all the way through. A parallel, on the other hand, has more than one path. So we call this piggybacking. It's taking one circuit and then it piggybacks another one off of it. So this light bulb actually has a separate path, but it shares the path with the first one. Okay, so that's a parallel, more than one path of electricity flowing. All right, so example of a series. So right here, we have a series circuit. It has an open circuit because the switch is open. So if it's up, it means it's open and it's broken. But if we were to close it, this would still be a series because there's only one flow of electricity going around. Okay, so that would be a series. Same with this one, it just looks a little differently. So we have two things on our circuit that we're going to power with a switch. Again, we'd have to put this switch down to turn it on, but this would be a series because there's only one flow of electricity. One way in, one way out. All right. So if we keep looking, now we get to a parallel. So this is three examples of parallel circuits. These are piggybacking, more familiar the way we showed it the first time. So this has three different circuits within one on our parallel circuit, right? It's piggybacking off of one another. So even though these light bulbs are broken, it's still able to let these other light bulbs illuminate because they have their own path of electricity. As we look at this example over here, where my face is kind of in the way, we have a light bulb and a bell with a switch. So only problem with the switch placement is if we turn that switch off, it's going to turn our light bulb and our bell off. If it's on, then they're both going to be on. But since they share that flow of electricity to that positive end of the battery, if the switch is open, it's going to be broken. But yet it's still another example of a parallel circuit. So remember, parallel, piggybacked, more than one flow. Series is only one big circle. Open, it's broken, and closed, it flows. Hope this helps. Bye, guys.